As tiny as the zebrafishes could be, they provide critical answers to human health, environmental safety, the development of medications, and can tell how chemicals in the environment can affect humans. Professor Robyn Leigh Tanguay, a researcher with the Department of Environment and Molecular Toxicology with the Oregon State University, U.S.A., organizes the largest number of researchers with these superfishes, which bear genetic semblance with us.
Zebrafish and humans share remarkable amount of DNA information. So 85% of the genes in zebrafish are present in humans. And most of the genes that we know are associated with human disease are also present in zebrafish. So really it's all of the processes necessary to have a human are really present in this tiny little embryo that develops very rapidly. So you can scale up experiments by the millions of animals to answer questions that are impossible to answer in any other model system. So we've adopted this model for about 35 years to answer questions of human health concerns, discovery of drugs. So it's a very relevant model for human health, even though it's a fish and it lives in water.
The Biochemistry and Biotechnology Department of the Kwame Nkrumah University of Science and Technology is working with these professors to explore how the zebrafishes can provide a better understanding of chemicals used in the artisanal small-scale sector, popularly called galamsey, and how these chemicals adversely affect the environment and humans.
The challenge of illegal gold mining is very acute. We saw it in person on our field trip yesterday. It's certainly one model isn't going to on its own solve any of these problems. The questions of the economics, the perception of the value versus the risk of destroying the environment. What this model can bring is rapid information to understand the chemicals in the environment that might be affecting children's development, for example. And in some ways, you can use the information from the zebrafish model as a communication mechanism to increase the awareness of the environment, of the people who live in these impacted areas.
Apart from destroying virgin forests and polluting water bodies, artisanal mining, otherwise galamsey, has left in its track dangerous chemicals like lead, mercury, cyanide, and copper. This has resulted in dire health consequences, including strange cancers, a spike in kidney and liver diseases, respiratory tract infections, and malformation of fetuses. Professor William Stubblefield, an Oregon State University environmental toxicologist with immense research in abandoned mining sites, warns that restoration could be costly.
And restoration of mining areas is very difficult to do, just because of the spatial extent of it, and the activity itself causes such problems associated with that.
The KNUST is currently growing these zebrafishes in its laboratory aquarium system, where they will be exposed to chemicals and residue picked from galamsey sites. Immunologist Dr. Alexander Kwame is positive the collaborative research is essential to protect lives and the environment from the ravages of galamsey.
In this country, and the lab of Professor Tanguay is one of the ones identified to be very strong in solving some of these environmental challenges, that we need to protect the environment to preserve the dignity of life. And so because of that, they came with a team to Ghana. We took them to the field to see the situation on the ground. And from here, we are going to sit on the table to discuss what are some of the practical strategies we can take to help some of these problems.
These zebrafishes, capable of laying up to 300 eggs in 1 week, can be harnessed to do large-scale investigation of how chemicals can affect lives right from fetus to maturity within just 120 days on large scale, an intervention that can provide quicker solutions within relatively shorter periods. For GH1 News, Ivan Heathcote-Fumado, KNUST, Kumasi.